Hello, this is Dave Thomas. A couple of days ago, I wrote a really simple macro in Elixir, and I thought it was actually instructive to have a look at how simple it was. So here it goes. The macro is returning. If you're a Ruby programmer and if you used Rails, you've probably come across the returning function or method in Ruby. It takes a parameter which it evaluates. It then passes that parameter to a block. It runs the block, and then when the block finishes, it actually ignores the value returned by the block and instead returns the value of its parameter. So it's a way of injecting some code just before you exit from a method or something like that. You might want to use it something like this. Here we have a method. This is again a Ruby method, average price, that takes a list of products. It converts that list into a list of prices, and then it averages it. And before we return that average, we'll just do a quick bit of logging just to show what's going on. So if we were to write that in Elixir, it would actually look very, very similar. It would be something like this. So the first line inside our function is the same thing. It takes the products and converts it into a list of prices. And then we want to return the average. So we'll assume we have some average function lying around. And we have a small problem, and that is that Ruby has these things, blocks, which will take a parameter. Elixir doesn't. So this little dangling parameter here is going to cause us a little bit of grief. So we have to work out how to handle that. To do that, let's apply Thomas's first rule of Elixir design, and that is never turn down the opportunity to use pattern matching. And in this particular case, we're going to use pattern matching as a way of getting a value into the code in the equivalent of that block. So using pattern matching would probably end up with something that looks a bit like this. Let's just isolate the code that we're looking at here, the returning block. So inside that block, you'll see we now have a pattern match. In this case, it's the single variable value. And what that means is that it will get any value whatsoever stored in that variable, and then we will run the associated clause, in this case the io.putS. But if we have pattern matching in this block, we can actually take it a step further. So here, for example, we're going to call file.open. Now file.open returns a tuple, either OK followed by the file PID or error followed by a reason. So inside our returning block here, we can actually distinguish between those two cases. If we get OK file back, then we're going to say a debug message. If we get an error code back, we're going to come back with a logger error level message. But in both cases, we're actually still going to return what file.open would have returned. So our caller gets to choose how to handle that. How are we going to implement something like this in Elixir? Well, it turns out to be really, really simple, and that's what I wanted to show you. Here we are at a terminal session. Let's create a new mix project. We'll call it returning. And we'll go into that project and let's edit the test file, because that helps us to get an idea of what we're actually going to be coding. So here's our returning test. And we'll start by having just a simple test to make sure that when we create a returning block, it returns the value of its parameter. So a returning block returns its parameter, something like result equals returning, I don't know, let's just say 1 plus 2, do, and then some empty block, and then we'll just say that we assert the result equals 3. Nothing too spectacular there. We'll save that away and we'll try running it. And you'll notice down here that the error is that function returning is undefined, and that's not really surprising. So now we're going to actually edit our file that implements returning. So I'll split the screen this way, and then over here we're going to edit the lib returning.ex file. I know I'm going to need a macro to do this, because what I'm doing is injecting code as I compile my Elixir program. So I know I'm going to need something called returning a macro, and it's going to take a value, and it's going to take a do block, and we're going to come back to that in a minute. Right now we're not using that do block, so I'm going to put an underscore in front of it. So a macro has to return a quoted block, which is fundamentally just the representation of Elixir code. So here I'm just going to have to say quote do, And to make this simple, I just want to return the value. Now, the value I return has to be this particular value here. And so I have to inject that. Now imagine I was writing a string. If I was doing this in a string, I would have to say something like the value is, and then hash open val. And this hash open bracket val close bracket is injecting the value into the string. So here what I want to do is to inject that value into the code I'm emitting. The macro equivalent of the hash brace notation is unquote. So here I'm going to unquote val and return that back out of the block. So here I have a macro returning, and all it does is it returns the code that's the equivalent of that val. Now if I save this away, it's actually not going to work, but we'll find out why in a second. So we save that away, and it says function returning is undefined, and that's because I haven't actually told it I'm going to use this returning module. So over here I am going to start by saying import returning. Now let's see what happens. It runs. So I've imported my module, and I have one test, no failures, which is good. So I'm not doing anything with the block here. So let's add something to the block here. So whatever value I get, just for now, I'll do an io.puts to say that. So now if I save this away, you notice my code still runs and it's not doing any tracing. Well, that's because over here, I'm just ignoring the block. I really want to do something with this block. And this is where we have to think a bit about what code we want to generate at runtime. And whenever I'm doing a macro like this, what I will typically do is somewhere down here, I will actually sketch out the code that I want my macro to generate. So what I have is a value, and I need to be able to do some kind of pattern matching on that value, and then effectively ignore the result of doing that pattern matching. So I have my value here. I'm going to do something like a case statement on that value. And then here I'm going to have the body of my block. This is where I have all the pattern matches and everything else. And then at the end of that, I'm going to return my value. So this is the code that I want my macro to create. So to do that, I'm just going to cut and paste this into my block here. So first of all, this val obviously is still, I need to use the value that's passed in. So I need to do that unquoting again. So I'm going to have an unquote here for my unquote val. And now I have to do this do block. And this is where it gets a little bit tricky. So how am I going to pass that do block in? Well, it turns out there's many, many ways of doing it. But the simplest way to do it is to look at what is actually getting passed from over here. So here I have my call to returning. My first parameter is 1 plus 2. And my second parameter is actually the do block. Now, inside a macro, what's going to get passed here is the code representation of that do block. And over here, case actually also takes two parameters. The first one is a value, and the second one is a do block. So what I could actually do here is simply take my block and unquote it like this. And that is going to inject the do block into the call to case. And in theory, it's just going to run my code. So let's just see how much of a fool I can make of myself here by saving this away. Variable value is unused, which is true over here because I'm using val. So let's replace that with value. Try one more time. And look at that. The actual reports got 3, 1 test, no failures. So we also know that the return of that block is not anything to do with the code that's being executed in here, because the return value is 3, and io.puts, I believe, actually returns nil. So clearly we have something working right here. So let's do one more little quick test. In this case, we'll test to make sure that we're actually doing a pattern match inside the block. So we're going to cut and paste this code. And so test returning block pattern matching do. We'll pass in just like a static thing, so maybe we'll say OK, little retro reference there. Okay, so that's what we're passing in. Inside our block now we can do some pattern matching. So the first pattern we'll match will be error and some variable, which we're not going to use. And if we get the error and the oops thing, then we're going to do an io.puts boom. Otherwise, if we get OK and some value, then we're going to report the value like that. And the result is always going to be our initial OK computer like this. So let's see what happens now. Again, we're going to run our tests. And here we go, 2 tests, both passed, and it actually correctly executed the OK clause here because the result is OK is computer, which is what we're outputting here. But clearly this isn't a particularly good automated test. How are we going to make sure that our code is being executed correctly inside the block? Now, if we're using a language with mutable variables, then what we could do is create a variable up here, what got executed equals, and then we'll set it to nil, and then down in here we could set it to one thing, here to another thing, and then see what the result was. But we can't do that because we have a language with immutable state. We could do it by using an Elixir agent, which is basically a way of running a background process. It can have its own state simply in terms of its runtime execution, and so we could do it that way. That's kind of complicated. There's another way of doing that. And what we'll do is we'll just send ourselves a message. So here, I'm going to send to myself the boom message. Otherwise, here, I'm going to send to myself the value. What I'm expecting is my mailbox is going to have one of those 2 messages in it, either boom or the value, which in this case is the string computer. So I can say assert received computer. Again, save that away. 2 tests just to double check that's actually being received. If I was to change that to be 1, 2, 3, then I actually get a failure here. No message matching computer 1, 2, 3. The trick here is to realize that the code that we're executing, whether it's a case or a do block or just a simple function call, all of that code is just represented during compilation time as Elixir data structures. And we can manipulate that just like we can any other data structure. So initially, it's kind of weird to think that here I have a macro that's actually being passed 2 chunks of code, but that's what's happening. This is not being passed 3. This is being passed the chunk of code that represents 1 plus 2. This is not being passed the actual tuple. It's a chunk of code that represents the tuple, which may or may not be the actual same thing at this point. Similarly, the do block here is actually relatively complicated. If you actually want to see what the do block looks like, we can actually put an inspect in here to do block and run that. And here is the do block for that second case. And as you can see, there's a lot of stuff in there. We really don't want to be groveling around inside that. So the trick is that we want to pass on that compiled code into something that can make use of it. And that's what we're doing up here. We're just simply passing that block across to case to say, here case, here is the do block that I want you to execute. And by the way, it came from over here. So it looks like we're up and running. Before we sprain a shoulder, patting ourselves on the back though, there is actually a problem in this code, and it's kind of subtle. And it is illustrative of the kind of difficulties you can get into when you do start using macros. To illustrate this problem, let's head back over to our tests, and we'll write just one more. We'll make it pretty simple. We'll say test parameter passing. And again, we'll have result equals. Now, for the first parameter to returning, normally that's a value. Here, I'm going to pass it the function call io.inspect Remember that IOInspect does two things. First of all, it outputs a string representation of its parameter, and then secondly, it actually returns that parameter. So this is going to pass the string hello into our returning macro, but after it's actually output hello to the console. So then we'll do that. We'll just have a simple block in the center here. Val goes to, we'll just do an io.puts on the value as well. And then we'll just do an assertion. Assert result is hello. And if we run this code, well, we got 3 tests. That's pretty good. What could be wrong with that? Except if we go back up here, you'll notice we have some kind of strange output. Here we have the first output from hello from inspect, and that is the string hello. Then we have the puts from the inside of our block, and then we see that hello in a string form again. io.inspect is being called 2 times. But over in our code here, we only have one instance of it. How can that be? Well, if we go back over to our macro definition, all is clear. Because inside our macro definition, you'll see that we actually call unquote on that val twice. Now remember that the val that we pass in is not the result of executing IOInspect, it's actually the code that does the IOInspect. So every time we call unquote, we're injecting that code into our result. And that means that we have 2 calls to IOInspect inside our macro body here that we're returning. There are a couple of ways of fixing that. If you have a look at the documentation for quote, you'll see that it has an option which is bind quoted, and that allows you to bind the value of a variable and pass it into the quote block. So we could actually bind the value of val and pass it in. It would only get executed one time. We cannot use that in this case though, because we also need to unquote the do block. And we can only do that in the context of something like case. Otherwise we'll get an error about that arrow operator. So instead we're going to do this a second way. We're going to take our code that's passed in and actually evaluate it just one time and assign that result to a local variable. So I can, for example, have a local variable called value, and I'm going to assign it to the result of executing val. So now this is going to be one execution of our IOInspect. And now here, whenever I used to call unquote val, I don't do that. I'll just use the local variable instead. So I'm just going to say value. So if we were to go save this away and go back over to our code, now we see 3 tests, no failures, and we only have 1 call to inspect. Just a little warning, it's very easy to fall into this kind of problem with macros. Basically, with macros, you can kind of bypass some of the purity of the functional side of Elixir. So in this case, we have what looks like a function parameter, which is pretty much defined to be executed one time, and we're actually executing it twice. You got to be really careful not to fall into that trap. So this comes back to a general rule, and that is don't use macros unless you actually need to, because they are more complex and they do lead to more subtle problems. It would be very easy to ignore, for example, this parameter problem when you're doing your testing. You go into production and then you discover that you're actually accidentally calling some very expensive function 2 times when you thought you were just doing it once. Macros in Elixir are a wonderful, wonderful tool. They're also really, really easy to abuse. The trick I find is never to use them unless I have to. The case I came across was I was writing a file and I was doing a lot of logging, and a lot of my functions ended up with something like result equals, then do some calculation, whatever it might be, log the result, and then return that result. So I'd have result equals blah, 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 log something, result. And I got sick of writing that time after time, not simply because it was typing, but because it obscured the meaning of my methods. So by having a return block or a return statement like this, it kind of made my code a lot easier to read. And so I thought, okay, I'll bite the bullet, I'll write a macro, and by doing that, my code got a lot simpler and actually also a lot easier to test, because it also meant that I could test the logging if I needed to. That's a real brief introduction to macros using Elixir, and I would just encourage you to go out there and play. It's a lot of fun, and you'll be able to do some really quite surprising things. Enjoy.